Before I start on lesson 8.5, I want to go back to lesson 8.4 and talk about a different method for solving equations that have decimals in them. And there's also another method for the fraction ones. It's just a preference on whether or not you want to work with the decimals, but going back to page 347 in your note sheet for lesson 8.4, there was method 1 and method 2. Method 2 would be to take your entire equation and multiply it by some power of 10 to get rid of any decimals. So what happens when I take the 10 times the 3.2? I get 32. Now using this method, anything in parentheses is protected from that. So we just get 32 times the quantity x plus 30.7 and then equals 10 times 4.8 is 48. And you might be thinking this really doesn't help because we still have the decimal. And you're right, it may not be a strategy you want to use. But now we have 32 times x, which is 32x, plus 32 times 3.7, 32 times 3.7 gives us 118.4. So I'm going to write down 118.4 equals 48, okay? And then we are going to subtract 118.4 minus 118.4, and we get 32x equals, and again, if you want to use a calculator, that's fine as long as you're showing the steps. I'm going to take 118.4 minus 48, and then I'm going to divide that 70.4 by 32. So 70.4 divided by 32, and we get 2.2. And actually it should be a negative because when we subtracted, we get a negative 70.4, and then divided by 32, and we get that 2.2. So again, it may or may not be a method you want to use, but we'll do some more in class so you can kind of see the benefit of using that power of 10 rule to eliminate some of the decimals. Okay. Moving on to lesson 8.5, you are going to be solving equations with variables on each side. And I went ahead and wrote in your what you'll learn statement. What does it mean by each side? It means that there are variables on each side of the equal sign. And in that case, we have a multiple step equation, 3 or 4 steps total. And we're still going to be looking out for those parentheses first. And then if we have variables on both sides, we're going to pick a side. It doesn't matter if you get them to the left side or the right side. We just need to pick a side for the variables. So in this section, you're going to be solving equations with variables on each side of the equal sign. Okay, so I added that in there for you. When I scroll down here, you have some little models, tiles that you can use to kind of see how that looks. When you have x's on both sides of the equal sign, you want to get them to the same size. So something you could take away from both sides is one of those x's, leaving you 2x equals 8. And then you have a one-step equation. So let's take a look at 1a at the bottom. We have 7x and 5x, and they're on opposite sides of the equal side. So we can either minus 5x from both sides or minus 7x from both sides. It really doesn't matter, but to save steps, I'm going to subtract 5x from both sides. So I get 7x minus 5x is 2x. And then on the right side, 5x minus 5x is 0, so we have 4 left over. Divide by 2, x equals 2. Okay. On 1b, we have 3x here and x here. Now you might say, oh, well, I can minus x minus x. That wouldn't be wrong, it's just you're setting yourself up for more steps. 3x minus x is 2x, minus 2 equals 0. Then you're going to add 2 to both sides and get 2x equals 2. Divide by 2, x equals 1. I'm going to rewrite that problem and do it the way that I would do it. 3x, minus 2 equals x. This x is already by itself on the right-hand side. So I'm going to get the 3x over there by minusing 3x. What's 3x minus 3x? 0. And if I go over here, minus 3x, because I do everything to both sides of the equal sign, I'm left with negative 2 equals 1x minus 3x is negative 2x. When I divide both sides by negative 2, I get the same answer, x equals 1. So again, it's not wrong to do it the way I first did it, but it's going to save you maybe a couple steps. Moving on to page 357, you have example 2 at the top, and that is where we have some fractions and decimals. Again, this is something I'm going to show you with that other method just to show you that it can be a nice method, especially when there's not any parentheses. So since I have the decimals here, I'm just going to take the whole equation and multiply it by 10. And I chose 10 because there's one decimal place behind each one. So I'm going to take the 10 times 2.1x to get 21x. I'm going to take the 10 times the 3 to get plus 30. I'm going to take the 10 times the 3.1x to get 31x. And I'm going to take the 10 times the negative 2 to get negative or minus 20. Okay? I have variables on the left and the right. It doesn't matter if you get them to the left or to the right. I'm going to subtract 21x from both sides. Why? It just leaves me with a positive number here. 21x minus 21x is 0, leaving me 30 equals 31x minus 21x is 10x minus 20. Again, I'm trying to isolate that variable. So I'm going to get rid of the 20 by adding it. Why adding it? Because it was subtracting 20. And the opposite or the inverse operation from subtracting is adding. So I'm going to add 20 to the left. 30 plus 20 is 50 equals 10x. Divide by 10, divide by 10, x equals 5. Okay, I'm going to show that strategy that I did with a 10, but in this case I'm going to multiply everything by a number that both 2 and 4 go into, so I can get rid of my fractions. And what is that number? That number is 4. So let's see how that looks. Put parentheses around the whole thing and put a 4 out here. What's 1/2 of 4? 2. So you have 2p. 4 times negative 15 would be negative 60 equals, what's 4 times 3/4? Well, the 4's cancel out and you're left with 3p. And then 4 times negative 3 is negative 12 or minus 12. Okay, I am going to subtract 2p from both sides. 2p minus 2p is 0, leaving me negative 60 equals 1p minus 12. Plus 12, plus 12, oops, and we get negative 48 equals p. Again, I went through those fast, but we'll do some more problems together in class to show you how that multiplying by 10 or multiplying by a common multiple can help you get rid of fractions and decimals. On example 3, we're translating a verbal problem into an equation, and then solving it. So $85 per day, and then a one-time fee of $75. And then King Cruises is $100 per day and a $30 charge. Write and solve an equation to find out what number of days where the cruises will be the same cost. So we have $85 per day x, 85x, plus 75 is equal to $100 a day, 100x, plus 30. Okay, I can either subtract 100x from both sides or subtract 85x. I'm going to subtract 85x because I'm dealing with positive numbers then. Okay, what I have left then is 75 equals 15x plus 30. Subtract 30 from both sides, and we get 15 equals, not 15, 45 equals 15x. Divide by 15, divide by 15, x equals 3. What does that mean? is that for the number of days, 3 days, the charges for the cruise will be the same. After 3 days, it's going to be more expensive for one of them. Okay? On 8.5, I also wanted you to look at the hot problem on page 359. Go ahead and figure out what the mistake was on number 32. Okay? And go ahead and figure that out in the box. Let me know if you have any questions.